Okay. Okay, so again, just put your numbers on the actual paper with your C number. Don't forget about that. And then also just scan the QR code just in case. But this is the final review that I'm gonna have at least. Now, if you were in my tutoring sessions before, I was asking for which chapters were the most requested. Most of you said chapter 18, 9, 11, and 12. So if you check this file, you're just gonna see problems from those chapters. That's it. I didn't put any other chapters because I was gonna keep making it way longer. So just for the sake of the 2 hours, we're just gonna focus on those 2 chapters. Sorry, in those 4 chapters. Yes. It should, yeah. As long as you use those as a review, you should be good. Yeah. So yeah, right now. Okay, so far we're good. There's one seat here, Mickey, if you want. Up to you. You don't have to move. There's one seat there, if you want. At the front. By Sam. Look at Sam. He's right there. There you go. But we're gonna start backwards. We're gonna start with chapter 18 first. It's the fresher stuff, and I hope that you guys remember it the most because it was the last thing that we covered. But, well, okay. Let's start simple. Chapter 18 was all about tautomers, all about your alpha hydrogens. So if they're asking for the keto-enol tautomeric pair, what's the answer in that case? What do we think? It is 2, precisely. It's just molecule 2. 1 is showing the keto form, but what's this? Is this a tautomer? No, it's just simply not. And then same process with the other ones. The last 2, they have a double bond, but they're misplaced. Exactly. How does the enolate look like? What's the difference? What do we say? It has a negative charge in the oxygen. Exactly. That's the only main difference. Okay. Now, let's start with the reactions. What's going to be the major product in this case? What kind of reaction are we trying to do? You are going to create the enolate, yeah, at some point. You are going to be adding. Why the less directly hinder? Exactly. Yes, it's been recorded and it seems like the audio, it is working. So yeah, you should have it. That's okay. Don't worry. If you need to go at any point to any other reviews, you're more than welcome to go. Okay. You guys are not stuck in here. You just can stand up and go. That's completely okay. So yeah, but don't worry. This one is recorded at least. So yeah. So yeah, this guy is just your alkylation. So remember, again, chapter 18 is all about replacing alpha hydrogens. This is my alpha position. I'm just going to replace one of those hydrogens for the carbon chain that I have. 1, 2, 1 and 2. That's it. Simple as that. Okay. So far, questions. What's the intermediate for this reaction? What kind of tautomer are we creating? I said it before. Enolate. It's the enolate. What would happen if I were to use an acid instead? It's the enol. It would be the enol tautomer. Okay. Let's do the next one. Major product. Whoops, sorry. Is that better? Okay. What kind of reaction are we trying to do there? What did we need for the haloform reaction? You need excess of the base. For every reaction in chapter 18, we need the alpha hydrogens. But specifically, the base needs to be in excess. But right now, what's that? What kind of molecule is that? Carboxylic acid. So this time it's acid catalyzed. So we don't even have a base. So we have an acid and Br2. So what are we doing? It's just a halogenation. So again, remember, those two are alpha positions. Do both positions have alpha hydrogens? No, exactly. This one is fully occupied. We can work with this one. So again, we just start copying the same exact molecule, but we add a bromine in the alpha position. That's it. Simple as that. Okay, so far questions with that one. Okay, pretty simple. As long as you know what kind of reaction you're doing, you should be good for the exam. Okay. Now let's do a similar reaction. They're asking for the chief product, which if you're taking West, you know that it just means that you're asking for the major product. That's it. So that one, it's a haloform reaction, exactly, because we see excess of what? We have a little comma right here. So it means that we have excess of the halogens, not of the base. So again, you have to be careful on what's presented on the arrow. So if we don't have excess of the base, specifically the base, exactly, it's bromine. So this one is not a haloform formation. So yeah, it's just a normal halogenation. Mm-hmm. There's two, but we don't have any alpha hydrogens in the bottom one. So, oh yes, we have two. Why two BRs? Not only that, what else? Because it's using a base catalyst. Bases in general, they're promoting polysubstitution of the alpha hydrogens. In that case, you would end up forming the same thing because we have excess, but normal quantities, acid is just replacing one. Bases, everything. One.
But then what would be the difference between, let's say, this exact reaction instead of Br2 excess as NaOH excess? That's a haloform.
That's a haloform reaction.
Or would you have the same exact product?
No.
No, be different.
In this case, yes. In this case, yes. Do we see why?
Let's say it was 3 alpha protons instead of the 2. With Br2
If it
excess.
was 3, then yes. You would form your.
So if it was this exact problem, but excess sodium, the excess base, it would still stop at the 2 bromine because there's still a carbon there to prevent it from.
Okay. Mm-hmm. So if we have Br2, for example, and OH minus in excess this time, what kind of reaction are you trying to do here? What was the requirement for the haloform? We did need to buy 3 alpha protons. That was one of the requirements. If we don't have them, we can proceed. We only have 2. 1.
In the situation where it's 3 alpha protons, but excess halogen, not base, are we still only replacing the 2 protons?
No, you replace the 3 protons with Br, but it would not depart the CPR. It would just stay on the molecule. So I'm sure she can draw it up.
You said BR2 in excess?
So I'm saying 3 alpha protons.
Oops, I have one extra.
And you have excess BR2.
Then OH.
Normal.
Yes.
The 3BRs on 3 alpha protons. No heliform reaction.
No haloform reaction, but again, bases, they promote poly substitution. So I'm grading this guy. Yes, that's the main portion. So the haloform, we do end up forming that, the one that is at the bottom right corner. But because we have excess of the base is gonna end up acting as a nucleophile. So that's when we proceed with a nucleophilic acyl substitution, what we saw in chapter 17, replace leaving group. That's it.
That's what the purpose of it.
Mm-hmm.
Okay.
There you go. That's the main difference. Okay.
Wait, what? Second.
Right, so if you have excess OH, right? you have 3 alpha protons.
Oh, yeah, but in the top right, you don't have the 30 alpha proton, so it's not gonna form out the heliform.
Yeah.
Oh, exactly.
No.
Yeah.
Actually, let's just draw it out so everyone can see it. Why not? Thank you. Did everyone sign up? I'm not missing anyone. We're all good?
You have to sign
Oh, you
switch.
did the-
Yeah.
Okay.
Okay, thank you. Okay. Well, wait. Too many. Okay, now similar reaction, but this time I have a terminal ketone. I have 3 alpha hydrogens available. So this time the reaction changes. It's not just a halogenation, it's a haloform reaction. So we know that at the end. I'm reusing the same one from tutoring. Do I have to use that one for SI? I think so, yeah. Sam, can you show me the?
Yeah.
Everyone's good? Okay, let's pass it. Sam, just pass it to Sebastian once you're done, but we're good. And then Sebastian, you're gonna pass it to Gustavo. Whoops. Exactly. This time I'm able to proceed with a haloform reaction. I have excess and I also have that methyl group on the ketone that gives me the 3 alpha hydrogens that I need. Mm-hmm. Yes. So again, always be careful on what's presented in the arrow. You can create different things as you just saw. Okay. Reagents, very similar. Initial molecule, very similar. But you have to see them together. Okay. Now, remember that chapter 18 is all about your alpha hydrogens, specifically because they are acidic hydrogens. So you guys should be able to identify what's the most acidic hydrogen in a molecule like that. Does that? Why did we say 3, Juan? Exactly. So what's the difference between 2 and 3? Say that again, Emily. Resonance. Number 3, it's the one that's able to do resonance and stabilize the charge.
Would that count as an allylic position? Right next to
That too, yeah, it is allylic. You are correct. Yeah. Okay, Sebastian, you're gonna pass it who's right behind you, and then we're gonna pass it to the other extreme to Gustavo. So, or we can move, yeah, that's okay, don't worry. Okay, so far questions on 18. So far we're good. Do we see the patterns? Okay. No. Last conceptual question that you might get on 18, at least for Dr. West. This one was very simple. So how do we solve a question like that? What are they asking us for? Yes. Racemic. The one that has the Carl center where? Exactly. It's 3. Because remember, the Carl center needs to be present in the alpha position. But not only that, we also need the presence of an alpha hydrogen in there. So the only one that fulfills that, it's molecule 3. Exactly.
What in alpha proton? Something else before the alpha proton.
You need a Carl center at the alpha position. Yes. Exactly. There's no alpha hydrogens, so it can't work. Okay. Any questions on 18? We're good? Okay, now if you're taking Dr. Roche, because I know that I have some students from that class, you guys have 2 more reactions, okay? Dr. Roche is going to include the full chapter 18 chapter. Wait, what? It's going to include all of chapter 18. So you guys have to review that on your own. I didn't include it in this review just because Dr. West is not going to include it. But you might have some problems with Christian at 6 until 8. He has a review too, so yeah. But that was the end of the chapter 18 questions. So we're moving on to chapter 9, everyone's favorite. Okay, let's start with this one. What's the approximate chemical value? This time it's CNMR, so don't confuse them. It's way higher, like around 200 or so. Don't worry, you don't have to know the specific ppm value. I just wanted you to test you on that same. You're good, don't worry. What's more electrophilic, nitrogen or oxygen? Oxygen. So it creates a greater de-shielding effect.
So if that's the case, why would it go about it?
But it's considered in the heteroatom region, which is slightly less de-shielded. The carbonyl provides more because it's not only the electronegative atom, it's also the presence of the double bond in there. So yeah. Okay. A lot of you wanted to practice this, the relationships between hydrogens. So what do we think?
Or yeah, they already answered something, not that serious.
The final answer? You guys are absolutely correct. Now, remember that whenever you get any relationship questions, you have to do the Q test. Now, for the Q test, once you do it, let's say that you're able to create a car center, like in that case. Now, if you don't have any other car centers, then they're considered anintotopic, which means that they're part of the same signal. But if we had a car center present in there, then they would be distereotopic, meaning they're different signals. So again, be careful on what you have in the molecule. And then 5 should be pretty simple, just very conceptual. It's just A. Vicinal, this is just describing the vicinal position, basically. And then if I were to change vicinal for geminal coupling, what would be the answer? Okay. Approximate chemical shift for the meta group.
That's either. What's C? Wait, no, it's either C or D. I'd say C because it's closer to the double bond in a lower position, so it'd be Oh, shoot.
Be careful. It is D. Yes. So in this case, they're testing you on chemical shift. Sorry. Now you guys can see it probably better in the back. So remember, this one is testing you chemical shift wise and multiplicity wise. Chemical shift, we're close to something that's D-shielded, something that's very electron dense, which is the double bond. But we have a little carbon in between, meaning that the D-shielding effect is not that big. It's not that strong. So it's protected. But we also know this is the aliphatic region. What's the range for the aliphatic region? 0 to 2.5. So after you identify the range that it falls under, you have to approximate it more depending on what you have around. So it should be around 1 because we're not that close to that double bond. Chase. So far, questions. We're good? So far, so good. Okay. Let's do a slightly more complicated question. Yes, one of those. You have everything. You have IR, you have HNMR, you're given mass spec. So you have a few data points in there.
But I want 120, I'm guessing it's the largest molecular mass, so I would just start by adding it.
Is that the most time efficient thing?
No.
It is not.
Well, then again, you can add them.
The 120 carbon peak would be around aromatic, right? That's aromatic.
Are you talking about the 120 over here? That one is just showing you the, yeah.
But you can't save time because you can calculate the mass versus benzene.
I mean, yeah, that too, but also if you're in the exam, would you see the time just running by? Maybe you're not the most comfortable with math, even if it's simple. So focus on H&MR. That's the easiest way. That's the fastest way. Okay. So we're only focusing on those portions. So just by knowing that there are two signals, can we start discarding some answer choices? Which ones? It's just one. Simple as that. It looks scary, but as long as you're able to simplify it, you should be good. It's just one, just based on the number of signals. Now, sometimes it's not as simple as that. Sometimes you're gonna have to look at multiplicity or other aspects. Okay, so just keep that in mind. Don't just rely on the number of signals. So far, so good. On which one? Yes. So in this case, all of the hydrogens in your benzene group, they're grouped together. That's one. Then the other one is just in the method group. Yes, the benzene is a multiplet. Remember, any aromatic rings, they're just considered multiplets. Abigail. A little carbon in between is going to create a more shielding factor. It's going to protect it a little more. Yeah, so the ppm value should be a little lower than 2.1. But yeah, I don't think they're going to go that really specific. So yes. Okay, now you probably forgot about this.
Wait, no, they're on the same terminal.
So the same one as you.
JB and JC. They're geminal, so it's. And you are correct, Sam. It is 12. So for this one, remember, you can either memorize the ranges or you can start just basically drawing out the little graph with the dihedral angles. Most likely, I highly doubt that you're going to get a question on J values or Hertz values in the final. But this one, I just included just in case because I know that most of you forgot this. So, yeah, he has. So it might not be on the exam. So, yeah, Mickey. It would have been around 7, yes, because they would be vicinal to each other, which is different.
I guess you don't know that, so when is it due then?
Whenever they are AW coupling, that's around 0 to 2 hertz. Then we have geminal, 12 to 15. We have vicinal, around 7. And then we have axial, 11 to 14. We have equatorial axial, which is 4 to 6. And then we have equatorial with equatorial, which is 2 to 5. So those are the ranges. And don't worry, you have access to them in the answer keys. It's just whenever the hydrogens are in completely different signals. Abigail. Yes, HB and HA, they're vicinal to each other. That's a really good question. And if you remember our discussion back early in the semester, there were 2 different versions because it depends on what your professors are looking at. Now, the safest bet was to just look at the graph, the dihedral angle graph, which, yeah, most students made that face. They don't like it because it's extra memorization. So I would just focus on vicinal and geminal. Those are the ones that they love to test the most. But again, this might just be one question. It's for sure just going to be one. It's not going to be multiple of those. Abigail. The dihedral curve? Okay, let's go back. Because I don't know how to describe it from scratch. But it's in the essay handout, if it loads. Right here. This little guy. No, this is not provided. You are providing it with your brain. That's it.
Yeah, I think I'm not for the whole
Okay, so far, any questions with J values? We're good, it's just mostly memorizing, and then everyone's favorite. Another one of those.
It's funny, these are the exact same questions from
It is, yes. I took it from one of your quizzes. If we remember this exact question, do not say the answer. If you're sure that you remember this. The elephant. They're gonna agree with elephant? Exactly. So again, you have to play it smart in this case. Again, time is limited. One of the characteristic things in that graph is the integration of 6H. So that usually means the presence of a little isopropyl group in there. Okay, yes. This one is your CNMR graph. Depth is the one that has the ones at the bottom and at the top. It's slightly different, but they pretty much give you the same data, same ranges. Mickey. Okay, so let's label these ones. A, B, and C. Whoops. This guy, we're just gonna write it. Whoops. Wait. These guys are C. This guy, it's B. This guy is A. No, remember that for CNMR, we never show splitting. For CNMR, the only factors are, yes. There's no multiplicity, there's no splitting or integration in CNMR.
So the length of the signal indicator, can we depend on that? Or
I am not sure. I wouldn't depend on that. Yeah, as long as you're comfortable with HNMR, you don't really have to worry that much about any other graphs. Okay. Okay, we're moving on to 11 and 12. This one should be pretty simple. Everyone, number 3? Beautiful. What would be the name of molecule 2? Beautiful. That one would be phenyl methyl ether.
You want the start volume
Which one?
one?
I do not know about that one. Not sure. Maybe ditoluene ether, not sure. Really not sure. It sounds cute, but not sure. It was a benzene connected to an ether only. That was anisole. That's anisole. Just the ether. Oh, yes. 2, yeah. It's not 3. It's 2. But yeah, remember that all of those names, like anisole, toluene, they're the common names for the molecules. They're not the IUPAC name. So remember, those things are different. Okay. I hope this one's easy. I really hope so.
Yeah. Propane that for rest of the
boron, that's
BH3. You're good. Mm-hmm. You got it, Mickey. It's your hydroboration oxidation. What were the rules for that reaction? Anti-Markovnikovs and syn addition. Great job, Kayla. Whoops, that's awful. Don't worry, calm down. Everything's good. Okay, anti-Markovnikovs, what does it mean? So yeah, that means our OH is gonna end up in this carbon, the one that's not connected to the meta group, which can be either 3 or 4. Now, the next requirement is the syn addition. What's syn to each other? The OH and the hydrogen have to be on the same plane, meaning that alcohol and methyl group are pointing to opposite directions. It's just 4. This one's pointing down, this one's pointing up. Because remember, this is given in a chair form, okay? This one is up and this one's up. So yeah. Okay, questions on that one? Okay, no problems. Yes. Which one? You're good. Don't worry. Yeah. The groups, they, in this case, the method and oxygen, they are trans to each other because the same relationship is only between alcohol and hydrogen. The new things that we add, that's it. Actually, product two. With what kind of reaction could I form it? Is your acid catalyze hydration or what else? Or oxymercuration. But that's great. So great job, Kayla. Okay. This one. Little multi-step synthesis. Which one did we say? Molecule two, does everyone agree? It is molecule two. No. First one. What kind of reagent is that? It's mesylate. Was it kind of like given in the product there? So yeah. It's just mesylate, which is a protecting group. No. Remember that when we were talking about those guys, we had group one and group two. What was the difference between them? One of them flips, the other one doesn't. Group one, it has PCl5, PBr3, SOCl2. Those guys, do they flip the stereochemistry or do they preserve it? They flip it, meaning that the second group, the one that has tosylate, mesylate, and TF, those guys are preserving the stereochemistry. So in the initial step, we preserve the stereochemistry, but then we have sodium with iodine. What kind of reaction are we doing there? We are adding a halogen, but we don't call it a halogenation. It's SN2. We do the backside attack. Great job, Emily. But yeah, those guys just your SN2, meaning that we flip again. The first step, we keep the stereochemistry. Second step, we flip. Mickey. Yes, don't worry. Okay, so let's draw the first one. So first one, again, I'm preserving the stereochemistry in there. I'm just replacing OH with O and mesylate. Exactly. We do SN2 because sodium goes away, you're left with iodine, which does the backside attack. Exactly. The backside attack is changing things. So now I have my iodine here, hydrogen here. And then remember, the ones at the bottom, I never touch them. So stereochemistry is going to be preserved at the bottom. One.
So we're saying that mesylates are, so you said mesylates and tosylates. Mesylates keep the stereochemistry, so they're reacting with the alcohol.
They are preserving the stereochemistry. Yes.
They react with alcohol.
Yes, because they're protecting groups. Remember, protecting groups in general, they're just swapping OH for whatever group you had, basically. So far, questions on protecting groups. We're good? One. No. Tosylate and mesylate, they were part of the same group. Group 2. Group 1 is the one with the halogens. PBr3, SOCl2, PCl3, and PCl5. Those guys, they flip. And we're back, Sam. What happened? That's okay. Okay. Let's write this one. There's a lot of condensed formula in there. So, okay, so in this case, in the question, they're telling you that you're forming 2-butanol. Butanol means a 4-carbon chain. So we have this guy, and in position 2, we have an alcohol. So that's the final product that I want to form. Now, all of the options in here, they're all starting with 1-butene. Butene, again, 4-carbon chain, but the in portion means that you have a double bond. You want the OH on the more substituted side. Which one? Yes, because this is your oxymercuration. What kind of product would I form if I use B? 1-butanol. There you go. D wouldn't work at all. I do not know. Usually HA we use to represent any acids in general. So, but that's weird. Yeah. It might have been a typo, but it would be the same thing as the thing on top. They would be the same. They would not be the same thing. Okay, so it is a typo. So in this case, it was supposed to be a little mercury, so G. Now, on the previous reaction, our solvent was water. That's why that was the answer, because we want to form an alcohol group. But if we were to use this one, this time the solvent changes. So it's going to be the oxygen with a metal. So yeah, they're different products. So yeah, you have to be careful with the solvent. So far, questions on that? Pretty much we're reviewing reactions that we learned back in Org 1. That's it. Say it again? Yes. Your acid catalyzed hydration, yes. That's the one that forms the carbocation, meaning that we can do the rearrangements. Exactly. Now, this one, it looks a little too full, but it's very simple. Read the question carefully.
go back to 134.
This one?
Yeah. Oh, okay, you're moving them to the left.
Remember that whenever you use protecting groups, you always end up creating a molecule with a good leaving group. So, substitution. Okay, can we go back to the other? Yes. It adds the methylated, yes. It's basically replacing the hydrogen with the methylated group. Yes, chlorine leaves for the methylate, and then whatever's left over, that gets added. Okay, let's go back to this one. Inserts, what do we think? E? Why is this the one with two BRs, Mickey? Beautiful. Here just gives access. So we know that at the end, we need to replace every single alcohol group, which means that it's E. Simple as that, guys. So far, questions. Julie? Yes. The doxy? Yes. This one's right here. No, you're not. We're just tired. You've been studying all day.
Oh, they said an acid.
Mhm.
That's right.
Exactly. So remember, the rule was that with any ethers, they can be cleaved in acids, but they're stable in bases. The only exception was epoxides. Epoxides, they're ethers, but they're a special kind. They are going to be reactive in both acids and bases because of the ring strain that we have in there. That makes it more unstable, therefore more reactive. Wait, actually, guys, it's been an hour. Do we need a little break? Are we good to continue? We can push through the second hour. We need a little break. Okay. Yes. Let's take a quick break so you guys can go to the bathroom, get some snacks, and then I'll see you guys at 5. So little break.
Draw out the methylate for one, and number two.
I can show you the methylate because I do not remember it from scratch.
You're
I
set for the rest of the
think it's
holidays on
here.
candy.
God, yeah. I was not expecting that. Right here. Maybe not here. Where's 11 and 12? That one.
I'll get it.
Yeah, good.
So that's the mesylate.
Mesylate was the single lady. She doesn't have a ring. Tosylate was the one with the ring. I don't know if you remember that.
Try to remember it. So essentially, this swaps in for the CL, giving you that little chemistry. Okay, lovely.
It's like having OMS with instead of a halogen. There you go. A little stress ball.
Gonna put it to use this week.
Yeah, you should.
Or is it?
Great question. Anything that's widely related is not graded. It's just there for extra practice. So once you're done with the content that your professors gave you, they're good practice. It's just extra practice. But again, yeah, no, don't worry. It says homework, but it's not graded. No, there is no tutoring tomorrow. This is our last day. Yeah, you do not have the ACS final. So it's not standardized. It's by your professors.
So just to sure, so B history is anti-Markov condition with sign is called, what's it called? I know the term for it, it's like hydro, it's basically the oxidation.
Hydrogen oxidation.
Okay, and the other one we just did for practice, the mercury one,
Oxymercuration, demercuration.
the reduction one.
Mm.
Well, I mean, it did reduction.
Is it here? Did we just went through it?
I think there was like a reaction, like it was like, I think it was like, it was this one. That was
This one?
That was basically oxidation.
So yeah, C and D, they are both oxymercuration, demercurations, but the difference was the solvent.
Yeah, the water.
Mhm.
Yeah, okay, got it.
Do you have a review for physics?
Not a review, just.
Oh.
Yeah, my lecture really. If that makes sense. Yeah. Professor kind of like freelance, he teaches, he doesn't really. have like a
I hate that, yeah.
big teacher. I mean, I'm
Oh,
like,
yeah.
it's like, what is in the-
Unless you go separately. But then that's a lot.
Actually, those of you who stayed, does anyone want Sour Patch?
I'll take some.
Okay, we'll take some.
Okay, that you can talk to me for this one.
Yes, it's in it upstairs. Actually, really quickly. So Christian is doing a tutoring review right now from 5 until 6. Sorry, a tutoring session. So you guys can work on any chapter you want in his tutoring session. Okay. And then he has a review. Okay. An SI final review. So if you want to join him right now, that's completely okay. Just stand up, go out through the door a little silently. But yeah. Yeah. Huh? This one? I can show it.
Question.
Mm.
Oh, sorry, for 189. Oh, we haven't got to that.
Oh yeah, yeah.
Is that a split in triple O, or is that?
God. Yeah, it was supposed to be a triple O. We just, yeah.
You know what's crazy about, that's not an instrument. Look at this couch,
Right, I got the.
then you got the L, yeah, and then you got the R.
Special.
You have Indian married.
Oh, that's the
Yes.
genetic version. What's the right version?
Harness, then it's third, right? See, you take out the R, yes, F. That's, yeah.
Could just call it right or nothing.
Would that be? Yeah. I am already there. I could have walked in, you know, this. No, no, it's. No, no, it's because I have this discussion all the time about my life. Yeah, and they're different things.
So animes are usually darker.
So anime is like that. Yeah, they have Japanese things. Like, I guess.
And Kayla, there you go. That's kind of like the full mechanism. Last portion, it repeats itself. So because I ran out of space, I didn't show it.
But. Yeah, but. Make a rule about. I don't know. I can't feel it. You have to know.
Oh no.
No license. More 4 hours for me. That's too bad.
Okay, let's get back to work, guys. Let's wrap up our conversations. Let's stop munching on our snacks, or at least doing it silently. You are right, but we did not start at 5:10, so. Exactly. Either way. This question. What's the product? What are you doing in the where? So it is peroxy acid. Okay. If you have a peroxy acid with a double bond, what do you create? Epoxide. Beautiful, Kayla. So you're creating this. Okay. So you have your little epoxide instead of the double bond. After that, what happens with NH3? What's that? It's a base. So we do base cleavage. No, I cannot. I'm so sorry, Sam. I personally do not know the mechanism. I highly doubt that your professor even showed you. So yeah, this one is just a matter of Googling it at this point or looking in the book. So either or. No, yeah, no. What was the main portion of the peroxy acids? How do we know we have a peroxy acid? CO3, CO3H. Beautiful. What was the ranking for base cleavage? So we cleave this one. What's the answer? What's the answer? 3. Great job, Emily. God, yeah. Do I still have Roche students? If you're a Roche student, raise your hand. Okay, we do have a few. Okay. So base cleavage for Roche, it was 1, 2, 3, the same as Dr. West. But for acids, it was different. Dr. Roche's ranking is 3, 2, 1 for acids. For West, which is the majority of the people right now, 3, 1, 2. Okay. So again, it depends on your professor. Do not ask me why. They just have that little argument. Next problem, guys. What's the answer for that reaction? Yeah. Oh God, you are absolutely correct. 1 and 4 are the same answer. Yeah. Same molecule. What kind of reaction are you trying to do there? SN2 is the second portion. SN2 is the second half. Very good. Don't worry. You're good. So first portion was just your acid-base reaction, and then the SN2 reaction follows. That pattern, what kind of reaction is? It does flip, but we have a name for this reaction. We start with acid-base, we end with SN2. It's like your professor. The West reaction. Thank you. So in this case, a West reaction, remember, again, you need certain components for that reaction, a base, an alcohol, and a halogen. In this case, we are given a molecule that has both the alcohol and the halogen within the same molecule. So it's going to be an intermolecular reaction. West is always creating ethers. So the only ether available is molecule 3.
Wait, but then the sodium hydroxide, is that, how does that?
Let's see. And then
Yeah.
Would it also be likely that sodium hydroxide, removes the PR?
in a way, yes. Because NaOH, that can also be considered a good nucleophile. So, yeah. So technically, you could create your, well, none of the answers are correct, but you can just replace the bromine with OH. Yeah, but that would be minor. What he's trying to test you for is the West reaction. Yeah, I didn't notice that when I was making this review. So yes, they're both the same functional group. Epoxides, that's usually whenever you see an intermolecular reaction. So yeah. Next one. Actually, right now, where is the attendance paper? Okay, it's in the back. Okay, you guys can just leave it there or you can pass it at the front. Whatever you want to do. It's okay. Okay, we're passing it to the front. What's the answer for that one? 174. It's your dear MCPBA, which it is a peroxy acid. Mm, 11. Yeah. I think so. Not sure. I would quickly Google it if you want the structure of MCPBA. We trust Google. Give me a letter. What's the answer? Gamma. Okay. So peroxy acids, we know that they make an epoxide when we start with a double bond. Cis-butene is just that guy. Now, we know that at the end, we just replace that pi bond with the connections to the oxygen in there. Okay. Now, because we're starting with a molecule that says, that means that the methyl groups in here, they're cis to each other and you're preserving that in the product. So it is 1. Do we see it? Yeah. Mickey? It was the same. Yeah. Okay. Next one. It's just given in words with IUPAC names. Mhm.
SACHM. So it's,
D? A as an apple? Okay, I have one vote for apple. Everyone got the apple? Okay. First of all, what kind of reaction are you doing there? Oximer creation. What are the rules for that reaction? It's just Markovnikov's. So we're adding on the more substituted side. In this case, you guys were almost correct, but you have to be careful with the solvent again. Oxymercuration, demercuration, depending on what kind of solvent you have, you can either create an alcohol group or an ether. So, now, what's the name of that molecule? Which of the answer choices? B as a boy? We all agree? And it is B. Yes.
then THFF takes both.
Then it would be A, exactly. FH2O. So yeah, don't always assume that it's just water. Always see what's provided for you in the arrow. $27. It's a little off, but you're starting with a carbonyl, you're ending with an alcohol group.
No, 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 if it was A, go all the way to the front, okay?
From the lithium aluminum hydride.
You're doing it backwards. What you're thinking about is an oxidation. Going from an alcohol to a carbonyl. It's both A and B.
Deep with the palladium, that's it.
Yeah. Yeah, it's just a hydrogenation reaction, but I wouldn't really worry about those reactions. They were mostly tested back in Argo 1. But again, main portion is that you have to identify what kind of change is happening in there. You're losing a pi bond. You're losing a connection to oxygen, meaning you're reducing. If it was the opposite, that's an oxidation. Now, for reductions, you have two reagents, A and B, lithium and sodium. But remember, ketones and aldehydes, they're not asterically hindered, meaning that they're really reactive. So they're going to react with something that's weak or strong. But what would happen if that was an ester? It would only work with A, with a strong reducing agent. This one should be simple. It's a little off, but still. Do not confuse them. Yes, you're missing your PCs. PCl3, PCl5. They are protecting groups. What? No, you're listening to your conscience now. You're each other's conscience, which they're wrong.
can acquire my contact.
Okay.
So yeah, do not mix up your PCs. We have PCC, which is an oxidizing agent. PCl3, PCl5, they're protecting groups. They're not the same thing.
Accident.
Yeah. Whoop, sorry. What happened? Hold on.
It's supposed to be a chain of three CH2.
That's your starter molecule and you're reacting with PCC. PCC, it's an oxidizing agent and it's a weak one. You're starting with what kind of alcohol group? Primary, secondary, tertiary? Exactly. See?
CH2.
Sometimes you're gonna see that presentation whenever they have a long carbon chain that's linear. They just include the unit that's repeating, like a polymer. So that's just an odd way of presenting it, but you might see it on the exam.
Tell you to repeat the CH2 times to form the form that I said.
This guy? That's your solvent. Combined with PCC, they oxidize. That's it. That's not the main portion of the reagent. You are each other's conscious this entire semester. Vineyard. That's an editing problem that I had. So we're gonna try to ignore that and let's just focus on the main things that you see. It's a retrosynthesis question. Does everyone think it's B? First of all, wherever you see the alcohol group, that was where the original carbonyl was. Okay, so
Okay, yeah.
if we're adding this guy, you have carbon groups on either side, whether you look at any of those 3 points. So carbonyl with 2 carbons on the side, what kind of functional group are you starting with? A ketone. Option B, what's this? It's an aldehyde. It doesn't correspond. So yeah, again, read the question and the answer choices carefully. You have to be mindful of what's there. You had a very similar question on the practice final for Dr. West. Absolutely correct. So in here, what kind of reaction are you doing? It's Grignard's. We see MGBR.
It's a little hard.
Exactly. Grignard's is a reduction. So we're only gonna touch the carbonyl. Only this guy. Now, reductions, whenever we did the mechanism, we never mentioned if it was a backside attack or a specific attack at all. So that means that I can create both enantiomers at the same time. So that's why it's both 1 and 3. And then main portion is that you never touch the carbon in there. You're not touching it. You're not messing with the stereochemistry. You keep it the same. Oh, we do have a club. I can't see it from here. Yeah. I just have the giant flag here, so it's blocking my view. That too, yeah. I can look at here, but not at that one. But either way, that's wrong. So answers. Again, be careful on what's presented in the arrow. Let's see. What's the answer? What do you think is gonna happen, Emily? Okay, so we remember that Grignard's was a little picky. If you had anything acidic, we wouldn't do a reduction. It would just be an acid-base reaction. But I told you guys that there could be an exception whenever excess of your Grignard's reagent is provided. That can override just the acid-base reaction and it can be able to form a reduction, which is molecule 2. I'm not sure if I mentioned it in SI, but if you went to tutoring at some point, I did. Yeah.
So we're saying that this wouldn't happen without.
Without access, no. Would just depronate it and then go back to the original molecule. Because it's an acidic proton. Remember, whenever we have anything acidic, Grignard's, instead of acting as a nucleophile for the reduction, it acts as a base. The answer wouldn't be 3.
It would just be the same, because if the H3O.
It would be 3, but without the mother group that's floating around on the left side. Multi-step synthesis. Mhm. Which ones can you eliminate? Exactly. Okay, so far we're good. We just use the oxy. Okay, so we have A. We think it's 4. Magnesium with ether. It inserts the magnesium in between carbon and halogen. This is making your greenish reagent. So we have MgBr, which we know goes away, and we're left with this guy. Now we have an epoxide. What are we gonna do?
Basic.
It's a base cleavage. We're presented with this guy, which is considered a base, and your epoxide. So we just attack it and cleave it open. And then we just protonate that alcohol group to get the OH. But then we have PCC, oxidation agent. Yes. Let me try it. Man, up here. Okay. And then for D, what kind of alcohol do I have? Primary, secondary, tertiary? Primary. Primary alcohols with PCC, what do they form? Aldehydes, because it's a weak oxidation agent. So it can be 5. It's 3. No. To get 5, we would need a strong oxidizing agent, like came in a 4. Then it would be 5. But if the alcohol group is like in the middle of the carbon chain, that would make it secondary, meaning that we would form option 4. So yeah, it's all about the combinations that we have in here. So far, questions, we're good? Okay. Okay. It's supposed to be the lithium reagent. Just look at the screen. Whatever's on the iPad, that's the actual time.
Just wait. See what Charlie does.
What's the answer for that one? Yeah. Sometimes your professor likes to present it as LAH. But what do we think? It is B, because it's a reduction. Because we're not gonna end up with any carbonyl groups. That doesn't make sense. No. A is kind of like in the intermediate, but we have a leaving group. So that's not showing me the correct product. This is kind of like showing me the intermediate-ish. Mm-hmm. So again, as long as you're able to identify your main reactions, you can play around with the answer choices. As long as you read careful the questions. So again, be careful with the questions. And then, yeah. Is this the last one? Nope, nope, nope. We have one more. Okay, this one. Should be simple. This question was provided by your own professor, so. Mm-hmm. And you're absolutely correct, Melissa. Because, whoops, that's not, whoop, whoop, whoop. This guy is B. Yeah. Yeah. Oh, yeah. Don't remember that your professor, the placement of the answer choices can be a little tricky. So again, just start separating it with lines so you don't get confused. So yeah, Mickey. Yes, 64, 65, one of those. But you have 2 hours. It's not in 1 hour. So yeah, too much. But okay, let's go through the last question. Yes. That's a lot. We're good? Okay, guys, before you drop that, last question.
Hold on, make sure it is the last.
It is.
Go cook in the kitchen, yes, let's go.
You're doing retrosynthesis. Which one? Okay, I have one vote for Apple. B. Okay, I have A and B. What do the rest of you think? So yeah. D and C do not make sense. The rings, they don't match up. You need a ring with 6 members and the other one needs 5. So. And then it is B. Because we can see that the alcohol group, which we know that was our original carbonyl, is connected to the 6 carbon chain. Again? Okay, we're dying slowly, but yes, wherever the alcohol group is, that's where your original carbonyl was. So for Grignards, I know that I need carbonyl plus alkyl halide. So I just split it right in half. This alcohol group is first connected to the ring with 6 members. So that was the carbonyl. So they look a little scary, but they're not too bad. And again, just read the questions carefully, do more practice problems on tomorrow. Well, tomorrow, yeah, tomorrow's your last day to study. And then remember, blue Scantron. I don't know if you need a calculator for the final. I don't think so, but you might. Well, I did not hear you. I'm sorry. So yeah.
I'll just put it on, yeah.
It should be in GN 101. GN 101 where the lecture was. Yeah, but double check it in the syllabus. Yes. And
I got it wrong and then. This is the base for chapter 18.
you're replacing your alpha plug again. Yeah. I think it could be. Yes. Before you guys start walking away, there's another review happening. If you want to stay, you guys can stay. He's gonna keep going with a handout. Okay, but if not, best of luck in all of your finals.
Have a nice break.
Thank you. Sorry? No. So yeah,
Yes.
he can post it for Dr. Roche's students.
Well,
It shouldn't take us that long, but I'll be honest, I don't even know if it's true.
we get 2.5 hours.
It's like, it's like 20.
It's like 5 hours.
And you can make a reference, but like, it could be like 5 things.
Yeah, I think we have a little bit.
I'm gonna.
Oh, sorry.
It's a gift. They gave you a little candy and I wasn't here and I was gonna give you candy, but I gave. It's a cat. Or a you toy, it doesn't matter. Thank you for all of your help. It's been great and I really appreciate everything.
Don't worry, he's gonna come. Just about a few more minutes. Bye, Shannon. Thank you. No problem. Good luck on your finals. I'm gonna do thank you. Like. And then